This is example 9 of improper. This is example 9 of improper integrals. Well, this is going to be an inverse trig. So if you want to skip this one, that's okay, because there's plenty of other ones. This one is weirdly. This is weirdly improper. It's improper because you can't put 0 in the denominator, and it's improper because you have infinity. So it's doubly improper. Okay, it's improper because it's infinity. It's improper because it's undefined at 0. So we're going to write this as limit as a goes to 0 from the right because it's the bottom. And we're going to go 0 to 1, I guess. So a to 1 of, so we want to rewrite it separately. Square root of x, x plus 1, plus the limit as b goes to infinity. So now we're going from 1 to b dx, square root of x, x plus 1. Some of you might be thinking, since our inverse trig comes up so often, shouldn't we know how to do this? Well, it really doesn't come up this often. I think it's just that some of these examples require inverse trig because they don't come out pretty for the other ones. And these come out nice and pretty, okay? All right, but I'm including this for completeness. If you skip this, that's perfectly all right. Okay. All right, so I'm plugging in, so I'm taking the limit. I'm integrating. Integrate this. So if I integrate this, remember I told you that was inverse trig. Turns out the angle is square root of x. All right, so remember inverse trig looks like this, 1 plus x squared. Well, this is 1 over 1 plus square root of x being squared, right? That's where that square root of x comes from, because it's what's the derivative square root of x? It's 1 over 2 root x. So I'm actually missing a 2. So I'm going to put a 2 out here. All right, so I'm missing a 2 here. To compensate for that 2, I'm going to put a 2 out here. So I'm missing a 2. So I'll put the 2 there. Okay, since you're probably not following this at all, don't worry about it. I needed a 2. All right, okay. All right, so now we take the limit as a goes to 0 from the right. When we integrate this is arctan of square root of x, taken from a to 1. Same ruling here, so I need a 2. Take the limit. And remember, since it's a number, it can just float out. B to infinity of arctan of square root of x from 1 to b. Alright, so this becomes 2, and I plug in these things, so limit of arctan of 1 minus arctan of a plus twice the limit, oops, that's a equals to 0 from the right, limit as b goes to infinity of arctan of square root of b minus arctan of 1. Alright, so what's arctan of 1? Arctan of 1 is pi over 4, and as a goes to 0, so that means it's going to 0, so that's arctan of 0 is 0. So this limit is just pi over 4. Right? Plus 2 times. Now here, as b goes to infinity, that's a b, that's not an x. As b goes to infinity, so that's square root of b goes to infinity. And then what happens to arctan as its argument goes to infinity? It goes to pi over 2. And arctan of 1 is pi over 4. It is 1 in it. So this becomes pi over 2. And pi over 2 minus pi over 4 is pi over 2. 2 times pi over 2 is pi over 2. So final answer is pi. Okay? Only one more video to go. You made this far.